Okay, so now it's recording. All right. So here's the document that I mentioned to you guys. And if we go down, oh, let me mention the general stuff. So I'm really big, all physicists are, on units. So I noticed on your pre-labs that I'm about to go through and finish grading. Thanks for getting most of them in on time. That there are some that are missing units. Normally, I would just immediately mark those off. This time, I'll probably go through and say, hey, don't forget next time. You can correct it this time. Basically, a answer in physics without units means nothing because it could be, is it millimeters, is it kilometers, or parsecs, light years, right? So those are important. I really, really want you guys to know these basically now. There's only 6 words here, and I'm surprised sometimes that people don't know these prefixes. So there's only 6 words here that you need to memorize, but these are the powers of 10, okay? Giga down to nano. It's pretty helpful to me that if, especially for long derivations, that you box your answers, for each section. And generally, the MKS system is meters, kilograms, seconds. Those are the consistent units for the MKS units. This, I already sent you an email, and so I just copied it here. So just to sort of show you what we're doing here, so you can see this screen here, the PDF. So you've already used the micrometer, and now you're going to use the vernier caliper to measure L and delta L for a random rectangle. When they say object, they just mean those random green rectangles. Which, let's see, I can bring that over here. This is the micrometer simulation. Okay, there it is. Right, so this is what you guys were already messing with. And you're going to do that. Okay, now, okay, so now I do have to bring this over here. So for error propagation, okay, which is what you are doing for section 1.5, this is quite a straightforward example. So if you look through that, the document that tells you about, there's 2 documents that tell you about errors. So which one do we have here? Error propagation review is here. So this is the equation that we're using. Delta volume is the square root of all this stuff. What does that mean? Well, if you have volume equals length times width times height right here, and you follow that equation through, then delta V equals the square root of all that stuff. Just follow the equation through, and then you'll see if you pull out the volume, LWH, it's a square root of delta L over L, etc. And so what this means is that the units of delta V are going to be the same as the units of volume. This is always true for errors. The units of error are the same as the thing you're quoting. And you can see that right here. LWH clearly has units of volume, is length cubed or meters cubed in MKS. And delta L over L, delta L is a length, and delta L over L is no units, right? And the same for width and height. So that's how that comes about, okay? And that's it. That's it for that part. Generally, as you all did, the error on whatever you're measuring, like with your micrometer, like when you do this, you're supposed to take your ruler that you have somewhere in your house. It's one of the few things that you need to just go find. You can also find some printable ones online if you really can't find one. But you go to a book, and it's true that some books have overlapping edges, especially hardbacks. Here's a couple of books I have. This one's called Gorilla Monsoon. Interesting book. It's a kind of an outdoors book. So if you measured length, width, and height of the hardcover, clearly you'd be overestimating. So you probably want to do something like this. Dune. Anyone know this book? Anyone ever read Dune? No, not yet. Maybe someday. There's a more modern movie coming out about it. Okay, this one, if I measured length, width, and height, I'd get the actual volume, right? So that's what you want to do. And your error on any of the dimensions should be the same. Is generally the way we say it is like if you have a ruler, is half of the smallest tick mark. So if your tick mark is, say, a millimeter, for a ruler, it's half a millimeter, right? 0.5 millimeters. That's you're being conservative. You're doing a fine job in estimating the error if you estimate like that. If you use that as an estimation, maybe you can measure better, you know, by eye, but that's sort of what we usually say. Okay, and now here's and I will do this here and there, and that's why you want to be checking this this doc. Is there are a few things that I note in red that are extra that are not in the lab manual. So one is write down the name of the book you used and record V and delta V of all your lab mates and the book they used and their book. Okay. This is just one of the ways that we have you interact with people and get to know people steadily. Okay. Now, for Eileen the swimmer, if you've done this simulator here, you start the simulator and you get to Eileen here, and you start her up, and she's swimming. Why is she swimming so slowly here? Well, if you go to paddles, I found out that the paddle strengths go from Parisian. Clearly, whoever wrote this was not maybe a fan of French strength or something, all the way up to Herculean, right? So you get to do all those. Then you have paddle period, mass, river current, etc. Okay, so I'd like you to mess around with those a little bit and just pick one, and then oh, okay. And so what do? You return, you plot, and then you can pause it, and you hit the time and when she's hitting different lengths. Now the time it tells you, so you have to assume the computer has zero error there, but these are at 25-meter lengths. You have some, some amount of error in measuring her length where she's at. Maybe it's a meter or something like that. You just estimate it, okay? So you estimate it and you write that down, and then you go through and you plot it on a plot. I don't have the sample here. This is what you're to do. You're to plot x versus t, in this case. X. Whenever we say something versus something, the first thing goes on the vertical axis, and then the second thing goes on the horizontal axis, x versus t, and then we draw a line of best fit. It's saying you can do this by hand. You can also do it on Excel right away if you want, or any other program. Okay, so you draw x versus t, you draw a best fit line. You can draw it by hand. You try to just go through all the points as best you can and determine the slope. That's your velocity, rise over run. Okay, and then you're supposed to interpret what does the y-intercept mean, and are your results sensible? Like, for one, could an actual human do this? Maybe. Just write some general comments down there. You don't have to give long essays for these. These can be brief. So another red thing here, write down the paddle settings you use, and also write down the speed your lab mates got and any differences in their settings. If they all have all the same settings, you could say that you're using. And so that actually is it. So let me go back to this and stop the video here.